You pick up a bright red apple from a bowl and give it a quick rub against your shirt, watching it instantly transform from a dull matte to a brilliant waxy shine. It feels like you are cleaning off dirt, but you are actually melting a layer of protection that the tree grew itself. Every apple is coated in a natural microscopic wax designed to lock in moisture and keep the fruit from shriveling up. When you rub the apple, the friction creates just enough heat to soften those wax molecules and spread them into a perfectly flat, mirror-like surface that reflects the light. It is a simple interaction between friction and biology that has been happening for millions of years. It reveals that the beauty of nature often comes with a built-in suit of armor designed for survival. Watch a single raindrop fall into a calm puddle. It doesn't just make a hole, it creates a perfect set of expanding rings. The moment the drop hits, it pushes water down and outward, creating a small crater. The water then rushes back to fill the hole, colliding in the center and pushing upward in a tiny column. This up and down motion creates a wave that travels outward in all directions. Each subsequent ring is a ripple of energy transferring through the water's surface, a perfect echo of that one impact. A single drop doesn't disappear. It transforms its energy into a beautiful, temporary pattern, demonstrating how force travels in waves across a delicate surface. You are sitting in a quiet room when you see someone across from you take a deep, wide-mouthed yawn, and suddenly you find yourself doing the exact same thing. It feels like a physical itch that you just have to scratch, and for a long time, we thought it was just about getting more oxygen. Science now suggests that yawning actually acts as a biological radiator for your brain. By stretching the jaw and taking in a big gulp of air, you increase blood flow and bring in cooler air to regulate your brain's internal temperature, keeping it alert. The fact that it's contagious might be an ancient social tool, helping an entire group of humans stay synchronized and vigilant together. It is a fascinating bridge between our individual biology and our social instincts. Even a moment of tiredness is a complex act of climate control for your mind. We look into mirrors every morning to brush our teeth or style our hair, seeing a perfect reflection of the world in front of us. It feels like we are looking through a clear window, but you are actually staring at a thin layer of liquid-like metal trapped behind glass. Most mirrors are made by coating the back of a glass sheet with a microscopic layer of silver or aluminum atoms. These metal atoms are packed so tightly and smoothly that light waves cannot penetrate them. Instead, the light bounces off instantly like a ball hitting a wall. The glass is just a transparent shield that keeps the metal from tarnishing or scratching. It is a daily encounter with the physics of reflection, showing how a sliver of metal can act as a silent twin to the world. You look up at your ceiling fan after it has been spinning for months and notice a thick layer of dust clinging to the leading edge of the blades. It seems impossible that dust could stay attached to something moving so fast, especially when the wind should be blowing it off. This happens because of a thin layer of air right against the surface of the blade called the boundary layer, where the air is almost perfectly still. Within this tiny, microscopic pocket of calm, static electricity acts like a magnet, pulling dust particles in and locking them to the surface where the wind can't reach them. It is a daily demonstration of fluid mechanics, proving that even in a whirlwind, there is always a pocket of stillness. It shows us that the laws of physics can protect the smallest speck of dust from the strongest breeze. That distinctive, pleasant smell in the air just after rain starts to fall on dry soil. It has a name, petrichor. For years, people wondered where this earthy perfume came from. Scientists discovered it's a blend of two main sources. First, certain plants release oils during dry periods that soak into the soil and rocks. When rain hits, these oils are released into the air as aerosols. Second, the impact of raindrops also kicks up tiny scent-carrying bacteria from the soil called actinomycetes. The smell is literally the scent of awakened earth, an aromatic signal that life in the soil is stirring. It's not just water you're smelling, but the memory of a dry spell being washed away. Place an ice cube in a glass of water and watch it float. As it melts, you might wonder, will the water level rise, stay the same, or fall? The surprising answer is that the water level stays exactly the same. An ice cube displaces a volume of water equal to its own weight. When it melts, it turns into liquid water that takes up exactly the same volume that the submerged part of the ice cube was already occupying. The part of the ice above the water line melts and fills that space perfectly. This is a perfect demonstration of Archimedes' principle, not with complex math, but with a simple glass of water. The floating ice is already holding its place for its future, liquid self. You are walking along the beach where the waves wash over the shore, and you notice something strange every time you take a step. As your foot presses down on the damp sand, the area around your toes instantly turns dry and pale, only to become wet again the moment you lift your foot. It seems like you are squeezing the water out, but you are actually doing the opposite by creating more space between the grains. This happens because the pressure of your step forces the tightly packed sand to shift and expand, creating new gaps that act like a sponge and suck the water deep underground. It is a counterintuitive phenomenon called dilatancy, where mechanical stress changes the volume of a material. It turns a simple walk on the beach into a lesson on how the earth reacts to our every move. On a sweltering summer day, you sit directly in front of a fan, feeling the immediate relief of the moving air against your skin. It feels like the fan is blowing cold air at you, but if you put a thermometer in front of the blades, you would see the temperature hasn't dropped at all. The fan doesn't actually cool the room, it simply speeds up the evaporation of the moisture on your skin. As the wind moves over you, it carries away the water molecules that have absorbed your body heat, leaving the cooler ones behind in a process called evaporative cooling. You aren't feeling a change in the weather, but a change in your own chemistry as your body sheds heat more efficiently. It is a beautiful example of how we can use the movement of air to manipulate our own biology. When you've been somewhere loud, like a concert or a crowded restaurant, you sometimes walk out into the quiet and hear a faint, high-pitched ringing in your ears. It feels like the sound is trapped inside your head. That sound isn't real. It's a kind of phantom noise created by your own brain. The tiny hair cells in your inner ear that detect sound can get tired and temporarily damaged from all that noise. When they stop sending signals to your brain because the noise has stopped, your brain gets confused by the sudden silence and fills in the gap, creating that ringing tone. It's a reminder that hearing is not just about your ears, but about your brain's interpretation, and that sometimes true silence is something we almost have to imagine.